In this video, we will be going over two-column proofs. Now, these are very similar to the idea that you all experienced last year with flowcharts. The difference is it's a little more organized, and you will more frequently see this on some kind of standardized testing. So we're going to transition over using the two-column proofs. In this, we are going to prove that these two triangles right here are congruent. And we are given certain pieces of information, as we can see, that are marked right here. So similar to a flow chart, we're going to start with our given. So my first statement, I can say xy is congruent to xw. Xy is congruent to xw. And the reason is because it's given. So then the next thing I can state is our next given, zy is congruent to zw. And this is also given. So again, every time you always want to state your given first. Super important. State given first. All right. So now that I have two pieces of information, I always need at least three to be able to conclude some kind of congruence between two triangles. So I need to figure out what my last piece of information is. Now what I notice is that triangle ZWX and triangle ZYX both share this side. So I can say that XZ is congruent to XZ itself by reflexive property. Now, we used to say reflexive property was same side. This is just another way to say same side. But most often on formal tests, you will see it as reflexive. The way that I think about it is it's like a mirror, so it's reflecting, it's reflexive. The next step, now that I have all three pieces of information, is I can make my conclusion. So I'm going to restate what's next to the prove part. I'm saying triangle X, Y, Z is congruent to triangle X, W, Z. And my reason is side, side, side. So congruence of side, side, side. The next example is also looking at the same kind of two-column proof. So for this one, I'm going to state my given, and then I need to find my third piece of information, just as the one before. So my given, I have AB is congruent to CD, and we said that's given. And angle BAE is congruent to angle DCE, and that is also given. So I have these already. I need to find my last part. So remember, if anytime you see a bow tie looking thing, there's a good chance that these angles right here are congruent. And the reason is it's vertical angle theorem. So these are mirroring each other right here. So I can say that angle AEB, so AEB is congruent to CED. You might be wondering why I'm using three letters. Three letters actually ends up being more descriptive. So if I had just said letter E or angle E, well, if I'm looking at where E is, there's actually four different angles right here. So I need to be really specific. The easiest way to describe these angles that I'm talking about is thinking about how I would draw it. So if I wanted to draw this angle E here, drawing from A, E, B tells me that I'm describing this angle here. So our reason again for this is vertical angle theorem, or VAT. So now that I have my three pieces of information, I can do my conclusion. So again, I'm going to rewrite what's next to the prove part, which is triangle AEB, is congruent to triangle CED. And my reason is angle, angle, side. So don't forget when you're stating things, wherever you start, there's nothing going on right here. So the first thing I'm starting with is angle. So angle is next to an angle is next to a side.